7th grade. Welcome back to school. I thought for our little extension here, we would actually review equations again because if I remember right from before break, things did not, we had a little issue with this, and a little review I think would probably do us all a touch bit of good, because there's nothing probably more important at this point in your mathematical careers than for you to grasp this whole equation thing. So if you want to, I don't know if it'd be good for you to start from fresh or all over again and get out your notes, or just, I would say, why don't you take out a whole new piece of paper and let's do it all over again from the beginning. Maybe I'll do a better job of explaining it. Maybe you'll catch on to it a little bit more. So again, we're talking about equations. And if you remember right, equations simply have to have equal signs. And the nice thing is, just like there's only 4 operations in math, you either have addition or subtraction or multiplication or division. Those are really the only 4 types of equations you can have. And I'm going to jump right into one here. Let's start with the basic simple one. Let's say I have x plus 6 equals 12. I'm sure you already know what the answer is. That, again, doesn't matter to me. We have to look at some processes here in order for us to get it. So when they're really hard ones, you can get it. Now, if you remember right, you can jot down a couple notes here. The notes would look a little like this. The first thing is, when you do these problems, if this is problem number 1 in the book, okay, I need you to write the equation down just exactly as it is from the book. So you're going to write x plus 6 equals 12 down. Okay, and you remember what our rules were. Our goal was to get the letter x all by itself. Okay, so the rule with this, I want to get rid of the stuff that's by the x, is the first thing is you're supposed to think opposite. In other words, you ask yourself, what type of equation is this? This is an addition equation. So the opposite of adding is, you want to do subtracting. Because if I subtract 6 from 6, I get nothing, 0. They go away, and I'm left with just the x. Remember, I need to see this on your paper. You put a minus 6 underneath that 6, scratch it off, it goes away, rewrite the x. But if you remember step number 2 was what you do to one side. If you do it to one side, you have to do it to the other. And you'll remember I brought out that little balance in Mrs. Stone's room, and when you took something away from one side of it, it was no longer balanced, it was no longer equal. That's the same thing with this. So if you subtract 6 from the left side of the equal sign, you have to also subtract 6 from the right side of the equal sign. And 12 minus 6 is 6. So x equals 6. Remember, on your paper, when you do this, I need you to show me all of this. It needs to look just like that. You write the equation down, you do the subtracting from one side, you do the subtracting from the other side. Everybody's happy, and you do well. Let's look at another example. So there was an addition example. What about subtraction? Okay, here's my subtraction problem. Let's say I have x minus 15 equals 30. It's a pretty simple little process here. Okay, you think opposite. This is a subtraction equation, so the opposite of subtraction is addition, and that's what you're going to do to both sides. You are going to add whatever that number is next to the x. I'm going to add 15 to both sides, and I need to see that on your paper underneath of this on the equation. Minus 15 plus 15, you can cross those off because they're opposites, they go away. You are left with simply the x. And then on the other side, it's 30 plus 15, you get 45. Just that easy. 45 minus 15 does give you 30. Wow, we are making some serious progress now. Now, what does a multiplication equation look like? Well, simply stated, it is just this. You have a number next to the letter. That is multiplication. 3 times x equals 33. Okay, 3 times x equals 33. What is the opposite of multiplication? Division. And the way I need you to show division on equations is it's a pretty simple thing. Remember, a fraction is nothing more than a glorified division problem. I just boop, put a line here. I divide 3 by 3. They go away. There's nothing left but the x. But what I do to one side, I have to do to the other. 33 divided by 3 is 11. Take my word for it. And please remember, it doesn't matter what side the x is on. It's always going to be the same. You know, if I had this, if I had 25 equals 5x, just because the number and the x is on the right side instead of the left, you still follow the same procedure. You want x by itself. It's multiplication. You do division to solve. 5 divided by 5 is x. And what I do to one side, I have to do to the other. 25 divided by 5 is 5. So 5 equals x is the same thing as x equals 5. You can flip-flop those around, no problem. And the one you don't see very often, but it does show up, is the division problem. And division would look a little like this. Let's say I have x divided by 4 equals 16. And these are one of those problems that are confusing because everybody sees 16 and they see 4 and they think the answer is 4. Well, if you follow our rules, you'll see that this is not the case. The opposite of division is multiplication, which means this. I have to multiply this side by 4. And since this is a fraction, I can make this a fraction, put it 4 over 1. And what happens when I have 4 on top and a 4 on the bottom? They cross off, which is what I want to happen. I'm left with just the x. Okay, I multiplied this side by 4, so I have to multiply this side by 4. And what is 16 times 4 but 64? And believe it or not, boys and girls, if you take 64 and divide it by 4, you get 16. So this all works. And remember, these are the ways I need to see the problems when you do them on your homework. Okay, I want you to do everything just as I did right there. Now, if you remember back to class, we had kind of one special example, and that is when you have a fraction in front of a letter. In other words, if I have 2/3 x equals 18, okay, and the one simple rule I gave you with fractions, just to simplify everything, is if you see a fraction, you flip and multiply. You flip and multiply, which means this. If my fraction is 2/3, I flip it over and I multiply by it. I take 2/3 and multiply it by 3/2. Why would I do such a thing? Because everything crosses out if you do that. I have a 3 on top that crosses off with a 3 on the bottom. I have a 2 on top that crosses off with a 2 on the bottom. This whole thing goes away. I'm left with just an x. But don't forget the fundamental rule of equations is what you do to one side, you have to do to the other. Since I multiplied this side by 3/2, I have to multiply this side by 3/2. And the nice thing here again is you can do some cross canceling. 2 goes into 18 9 times. 9 times 3 is 27. And there would be my answer there. So remember, we will talk about it multiple times. Fractions in front of letters, you flip it, multiply. Let's do one more example. Let's say I have 35 equals 5/7, and let's just change this to the letter B, just because it doesn't have to be X, it can be any letter. So here again, we have a fraction in front of a letter. What am I going to do if there's a fraction? I flip and multiply. I flip 5/7 over, I get 7/5. Again, it's the one next to the letter that I'm flipping and multiplying. I'm not flipping and multiplying by the 35 because it's not next to the letter B. What happens over here? My numbers, my fraction crosses off. I'm left with just the B. But what I did to this side, I have to also do to this side, so I need to multiply it by that 7/5. And luckily for us, this all crosses off again. 5 goes into 35 7 times, and 7 times 7 is 49. B equals 49. So hopefully 7th grade, that was a nice review. Hopefully we made a little progress here, but I cannot state again, I need to see your work just like I did in all of these here. Okay, I need to see it that way. You need to show me what you've done, up and down and sideways and all that stuff there. So hopefully, like I said again, that helped you out. And we hope to see you soon. Goodbye.